Today we are moving into lesson 8.3, which is about factors of counting numbers. Factors is a word that you should be familiar with, so thinking about that as we're moving into today's lesson will be important. All right, let's start with mental math. Write the missing factors. So remember, a factor, you should be able to look at this number model, 2 times question mark equals 10, and realize what you're looking for is that question mark. Question mark right there, that missing number is going to be a factor. A factor is a number that you multiply in order to get the product. So for example, 3 times 5 equals 15. 3 and 5 are factors of 15, which is the product. All right, so let's look at these problems. What are the missing factors? 2 times what equals 10? You should have said 5. 18 is what times 9? So that one's written just backwards, but it doesn't matter. 18 equals something times 9. So that would be 2. 2 times 9 is 18. And then 3 times what is 30? 3 times 10 is 30. So those are factors for these problems. Let's try some more. So what times 3 is 18? 8 times what is 64? And 36 is what times 4? Go ahead and pause the video if you need to and write down those 3 answers. You should have said 6 times 3 is 18. 8 times 8 is 64. And 36 is 9 times 4. Good job if those are the answers that you got. If you didn't get those answers, think about why. All right, and then here's our last slide for these. 56 is 8 times what? What times 9 is 72? And 42 is what times 7? Pause the video if you need to for a little bit more time. So we remember 5, 6, 7, 8. 56 is 7 times 8. So 56 is 8 times 7. 8 times 9 is 72. And 42 is 6 times 7. All right, our math message for today. Let's look at this problem and think about what we know. Joanna packed 16 bottles of juice into cartons. How could she pack the bottles so that each carton has an equal number of bottles with none left over? Show your thinking with pictures, arrays, and a number model. Now, I want you to know that there is more than one right answer. So I want you to try to figure out how many different ways could she put the bottles of juice into cartons. So let's look at our question. How could she pack the bottles so that each carton has an equal number of bottles with no leftovers? So it's important, well, let's also pick out our numbers. So we have 16 bottles, and that's really all that we know. We don't know the number of cartons. We're trying to figure out how many cartons could she have full of bottles. Now, it's really important to know there are no leftovers, so you can't have any that are not in a carton, and all the cartons have to have an equal number. So you can't have any cartons, like if one carton has 5, all the cartons have to have 5. You can't have one carton with 5, one with 4, and one with 3. They all have to have the same number. All right, so on your paper, go ahead and figure out how many different ways do you think she could pack 16 bottles into cartons with no leftovers and an equal number into each carton. Pause the video now so you can do some work. All right, let's talk about some ways that we could do that. So let's say we have 16 bottles. How can I arrange my 16 bottles different ways? Well, I know that I can count by 2s to get 16. So I could do cartons with 2 bottles. 2, 4, 6, 8, 10, 12, 14, 16. There's 16 bottles. They all have 2, and I don't have any leftovers. So let's think what I did. I did 2 times 8, and I got 16. I had 8 cartons with 2 in each. How else can I get 16? Well, I also know that I could do 4 bottles in a carton. So there's 4, 8, 12, 16. So that was 4 times 4. So I know that 2 times 8 gives me 16 and 4 times 4 gives me 16. I cannot count by 5s to get 16 because I know when I count by 5s, I do 5, 10, 15, 20. So if I had cartons with 15, I'd have 1 left over, or I wouldn't have enough to fill up cartons for 20. I also know that I cannot count by 3s to get 16. 3, 6, 9, 12, 15, 18. I skipped right past 16. So these are the only 2 ways that I can have cartons with an equal number in each carton and no leftovers. So 2, 8, and 4. 2, 4, and 8. These are factors of 16 because I can multiply by 2, 4, and 8 to get 16. 2 times 8 is 16, so 2 and 8 are factors of 16. 4 times 4 is 16, so 4 is a factor of 16. All right, so now what we're going to do is use drawings or counters to model packing 16 bottles equally into 5 cartons. 16 bottles, 5 cartons, and you're going to make sure they are equal. Pause the video and take a second. So first I need to draw 5 cartons. Then I need to take my 16 bottles and spread them out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh no, I messed up. Hang on, let me fix that. Let me go back a little bit. Sorry about that. So let's see, 2, 4, 6, 8, 10. There we go. 11, 12, 13, 14, 15. Oh no, I have a leftover. So since I have a leftover, I know that 5 is not a factor of 16 because 5 does not go into 16 equally. All right, today we'll practice finding factor pairs for a product. So pairs, factor pairs, means 2 numbers that go together in a pair to make another number. So for example, 2 and 8 are factor pairs of 16 because 2 times 8 is 16. Let's practice. How could you pack 10 bottles of juice into cartons so that each carton has an equal number of bottles with none left over? So after I read the story problem, I know that I have 10 bottles and I want to put them into cartons. And I can't have no leftovers and they need to be equal. This is just like the one we did with 16, but now we're using the number 10. So basically, I want to find the factors of 10. So what are the factors of 10? What I need to think about is how can I multiply to get 10? Now let's look at this multiplication chart. If you think about all of the numbers on this side are factors, and these are factors. All of the answers on the inside, these are all the products. So let's think about how we can get 10. I'm looking on this and I see that the only place I find 10 is here and here. So 10 doesn't have a lot of factors. The only factors of 10 are 5 and 2. So the factors of 10 are 5 and 2. 2 and 5 is a factor pair of 10. I can also do 1 and 10. Kind of forgot about that. 1 and 10. 1 and 10 is also a factor pair of 10. 1 times itself is always a factor pair of every number. Every number you can multiply by 1 and get itself. So factors of 10, it has 2 factor pairs, 1 and 10 and 2 and 5. You cannot multiply by 3 or 4 or any other number between 1 and 10 in order to get 10. All right, let's look for factor pairs of 30. So let's think about how can we multiply to get 30? 30 is our answer. What can we multiply by? When I do this, I like to start with my lowest number. Can I multiply by 1? Yes, I can. 1 times what gives me 30? 1 times 30. Correct. Now, can I multiply by 2? I know because 30 is an even number, it ends in a 0, I can multiply by 2 to get 30. So 2 times what gives me 30? What added to itself equals 30? If you said 15, you're correct. All right, now 3. How can I multiply by 3 to get 30? Can I do that? If you said 3 times 10 is 30, that's correct. All right, now I go to 4. 4 is a little bit trickier. So I'm going to practice counting by 4s to see if I can get to 30. 4, 8, 12, 16, 20, 24, 28, 32. Ooh, I skipped 30, so 4 does not work. Let's go to 5. I know to multiply by 5, my answer ends in a 5 or a 0. 30 ends in a 0, so I should get there when I count by 5s. 5, 10, 15, 20, 25, 30. That was a 6. 5 times 6 is 30. Now, when I get a factor pair where the numbers are right next to each other like this one, 5 and 6, then I know that there are no more numbers that I can multiply by to get 30. I don't need to go any further because 5 and 6 are counting numbers that are right next to each other. There's nothing between them to multiply by, so these are the factor pairs of 30. 30 has factors of 1, 2, 3, 5, 6, 10, 15, and 30. All right, let's think about 120. Ooh, that seems like a big number. But what we can think about are extended facts like we learned yesterday. So instead of thinking about 120, let's think about the basic number, which is, anybody? 12. All right, so let's find the factors of 12 first. So 12. How can I multiply and get 12? Well, I know I can do 1 and 12. Always. Now, I'm going to leave a little bit of space right here, and we'll talk about why in a second. All right, I know I can do 2 because 12 is even. So 2 and 6. Can we count by 3? 3, 6, 9, 12. Oh, yep, so that's 3 and 4. Now, when I get to 3 and 4, the numbers are right next to each other, so I don't need to go any further. So 1 and 12, 2 and 6, and 3 and 4 are the factors of 12. But I really want to know the factors of 120. So I'm going to add my 0 here and say, oh, I'm looking for 120. So now all I have to do is take my 0 and add it in. So 1 times 120, 2 times 60, and 3 times 40. Now, the other way, when you switch 2 and 6, and it's when you're finding the factors of 12, you can't just say it's 2 and 6 and it's 6 and 2. That's the same thing. But for this one, we could also say it is 10. We're just switching the 0 times 12. Do you see what I did? I put the 0 over here that time. We could say it is 20 times 6. Just switch the 0. Or 30 times 4. Just switch the 0. So as long as I have the 1 0 in one of the numbers, those are going to be factors of 120. So the factors would be 1, 2, 3, 10, 20, 30. Oh, I skipped some, sorry. 1, 2, 3, 120, 60, 40, 10, 12, 26, 30, and 4. Those are all factor pairs for 120. All right, some independent practice today. You're going to work on Math Journal, page 259, and then Math Boxes, page 260, and then log into MobyMax and do your math facts.